Solving a system of linear equations by substitution. So here we have the two equations of the two straight lines in different formats. Notice in the first one, y is isolated already. In other words, it's one y and it's all by itself. Now I've highlighted the y's in red in both cases. The reason for that is that where they intersect, the y values and for that matter the x values are the same at that point. So that's what we're going to be able to use to do our substitution. Here I've written the same two equations out again, but this time we're going to substitute 2x minus 1 in place of y in the second equation, because 2x minus 1 is the same as y, it equals y as we're told here. So here's what our substitution looks like. I'm going to replace that y. Replace is just another word for substitute. So we're going to replace it with its equivalent value, which is 2x minus 1. Now I need to bring these brackets in here because it needs to be shown that the 4 is multiplied by that entire expression. So now the second equation that did say 3x minus 4y equals negative 11 now says 3x minus 4 2x minus 1 instead of y equals negative 11. So the only thing that's changed is the y has been replaced by 2x minus 1. Now we're home because we know how to solve an equation with one variable in it. We expand the bracket. Becomes negative 8x plus 4. Then we collect our x's on the left side and our numbers on the right side. Then we divide both sides by negative 5 and you get x equals 3. That gives us the x coordinate of the intersection, so now we need to put that x value into one of those two equations, 1 or 2, to find what the y value is when x is 3. So the simpler one to use is the first one. So y equals 2x minus 1 becomes 2 times 3 minus 1, which is 6 minus 1, which is 5. So there's the ordered pair, the answer. 3 comma 5, x is 3, y is 5. And just to sort of confirm it, here's a graph to show us those two lines where they intersect is indeed 3, 5. Now that equation, y was already isolated, so it was fairly clear what we should substitute where. The next one is not quite as straightforward because there isn't a letter isolated here. There is an x value with a coefficient of 1, so that'll be the easiest one to isolate. So that's what we've done here. X is negative 3y plus 11. So we just moved the 3y over to this side and made it negative. So negative 3y plus 11. And the second equation is unchanged. So now we can do that substitution. Again, equation 2, 4x plus 5y equals 16. We substitute the x replaced with this 3x plus 11, 3y plus 11. Again, because they're equivalent, we know that x is equivalent to negative 3y plus 11. Brackets there to show that we're multiplying the 4 by that entire expression. And once again, we've got one unknown, y in that equation. So we solve it, expand the brackets, negative 12y plus 44 plus 5y equals 16. And you solve that, negative 7y on the left, negative 28 on the right. Divide by negative 7, you get 4. And then sub that back into one of those equations to find what x is when y is 4. So I chose equation 3. So x equals negative 3 times y, which is 4, plus 11. And negative 12 plus 11, x is negative 1. So that's the ordered pair, negative 1, 4. And once again, we have graphical confirmation of that. Negative 1, 4 is where those two lines intersect.